All right, ladies and gentlemen, as I promised, we're gonna do problem number 8 from your handout from chapter 3. And this is more of a complete view of a projectile motion problem. So here you have a projectile that is shot from an edge of a cliff, just like shown in a picture, from the ground level of the cliff, that is, with the initial velocity of 65 meters per second. Yeah, and an angle of 35 degrees, so we can see them already in the picture with a horizontal. And then from there you are asked to find a multitude of things, and we're going to go one over. And I wanted to add something else actually at the very end, if we have time, the total height from the base of below the cliff all the way to the total up. So let's start with point A. So first of all, I'm going to depict here some of my, we have h equals 115 meters. I mean, I shouldn't put a here. We're just going to get the data first. So always on a physics problem, try to extract everything out of the problem before you start. That will make your life a lot easier, yeah? V naught or V0 or V initial, 65 meters per second. Yeah, remember that this is V0x, yeah, it's constant. And not only that is constant, is equal to V0 cosine of theta. Yeah, we can call it theta 0 or theta naught. And then V0 on the y is equal to V naught sine of theta naught. And what else do we have is that theta naught is 35 degrees. And that's all we have. Okay, so in part A, you are asked to determine the time taken by the projectile to hit point P, so to make it all the way to the ground. So in other words, how much time does it take the projectile to go on this path, essentially? Very well, so I'm going to start with, so let me put here T index total. We can put that in seconds. That's what you are asked to find. So let's write down the equation first of all and look at it, right? So what was the general equation on the y direction? Y equals y naught plus v0y times the time plus 1/2 acceleration on the y direction times t squared. Now, what I want to depict here in this problem, which I think it's important, right? Because the projectile starts moving up first, I am going to take the positive direction as being moving up. That means no matter how I look at it, acceleration on the y direction is negative g because it's going down. That's why. So hence, when you put this into the problem, you will have it. It's easier that way to think about how you put it in. So when I talk about this equation, we want to consider the point of origin being this point right here. So that's your point of origin. That means I'm going to consider that my I would say, why not, right? And then the point of final is point P. And the difference between the two of them is nothing else but y minus y naught, yes? And let's see. Now we can look a little bit better here. So y naught is 115 and y is 0. So I can replace that in my equation now. But first, let's just plug in what we have. Instead of V0y, we know that becomes V0 sine of theta naught, yeah, times t. And then acceleration on the y direction being negative, you will end up with negative 1/2 gt squared. What I wanted to do first is give you a picture as far as just in algebraic mode. Since you are here asked to find a total, I want you to notice that this is a second degree equation, yeah, ax squared plus bx plus c equals 0, where a is negative 1/2 g, where b is v naught sine of theta naught, and where c is equal to y0. So remember when you calculate the solutions for a second degree equation, right? Let's say x12 is negative b plus or minus square root of b squared minus 4ac divided by 2a. Yeah, so remember that. This is an equation, second degree equation. So here you go. ax squared, here's bx, and here's c. Yeah, so I'm going to And then it's easy for you to identify who are the coefficients. So with that said, let's plug in this here. So when we calculate the solutions here, they will be for time. So T12 is equal negative b. So negative v naught sine of theta naught, right, plus or minus. And then you're going to have a long square root of b squared, so that will become v naught squared sine square of theta naught, yeah, minus 4. A is equal to y0, yeah, and then c is equal to negative 1/2 g. Okay, now all of this is divided by 2 times a, which is negative 1/2 g. And that's the reason I chose this problem, because I'm sure you have some like this in your homework. Now let's simplify things that we can simplify. So for example, this 2 and that 2 will go away among the denominator itself. And this 4 here and that 2 will go away, so that will become a 2 and that will become a 1. More so, the 2 negatives here, negative 4 blah blah times another negative, that will end up being a positive. Okay, so let's continue now. So T12 is equal to negative V0 sine of theta 0, or V naught, whatever. Okay, so we have plus or minus square root of V0 squared sine square of theta naught. And this will become plus 2GY naught. Okay, divide that by negative g. Now I want you to pay attention to something, because you may get confused about these signs, but I will explain something. If you factor out a negative on top and bottom, these signs here, the pluses and minuses, it will just become a minus and a plus. That's all there is to it. And why would I do that? Just to get rid of the negative that's in the front, right? So by doing that, you get T12 equals V0 sine of theta zeros minus plus square root of all of that, V0 squared sine square of theta 0, plus 2GY naught divided by g. Now that you have it, you just have to plug in all your numbers. So let's see what do we get if we plug in the numbers. So we have something like that, 65 sine of 35 minus plus square root of 65 squared times sine square of 35, right, which is sine of 35 times another sine of 35, plus 2 times 9.8 times 115. All right, and then we're going to just divide that by 9.8. Okay, you can use a calculator, and actually I wanted you to practice. I tell you what, if you're not sure and if you don't want to lose numbers, just do each part separate. Do it this separate, do this guy separate, and then that one, and then you add them, then square root, and then it's a lot easier to make sure you don't commit any mistakes. I will tell you what we get here. We get one of them is going to be 9.964 seconds. And the other one, it will be a negative number, negative 2.355. Now, the time cannot be a negative number, okay? So this one goes out because can't be less than 0. So what you end up with having is your total travel time, which you are asked to do. Okay, let's do that again. That's your total travel time. I'm going to put it here in words, total travel time. And this is how we do part A. Now, part B. Let's see what part B requires. If you look here at part B, they ask you determine the distance x of point P from the base of the vertical cliff. In other words, they ask you how much is this range, okay? So as you notice today, when you learn all the formulas, this part is actually very easy. The range, or delta x, or simply x, is the velocity on the x-axis times the total time of traveling. Vx being constant, that was v naught cosine of theta naught that is your velocity on the x-axis, times the time that you just calculated in part A. So my total range, or x, whatever it is, 65 times cosine of 35, and times the time that we had above, 9.964. If you plug all of this in a calculator, you get about 530.53. If you want to round it to 0.5, that's fine. I'm just gonna report the number right now. And you know, it's a good practice for you to do this on a calculator to actually make sure you get these numbers. I've done them and I wanted to make sure you all get the same thing. Okay, part C of the problem. Okay, on part C, you are asked to find the horizontal and the vertical components of its velocity. So essentially, this is another easy one because you already have, do they ask you at point, horizontal and vertical components of its velocity? Okay. So in other words, you are asked to find what are the components of the velocity of that point. So let's go ahead and put the components. We already have the Vx because Vx is constant and is equal to V naught x or V0x, which is V naught cosine of theta naught. And that was 65 times cosine of 35 degrees. And that ends up being about 53.24, again, meters per second. Yeah. Okay, as far as the velocity on the y direction, that's the original velocity, right? V naught y plus at. And that is the general form, right? So if you want to calculate the velocity at the point right before it hits point P, right before it hits the ground, it's nothing else but, I'm going to make the drawing here. So assuming here it's point P, right? The velocity on the x-axis is all constant. So that was V naught x equals to Vx, yeah. And then on the y direction, you may have some like that. And I would say Vy. And then later on, you're probably going to be asked to calculate the vector and the direction. So we'll call this V index P. That means the velocity right before you hit point P. So right now what you're having, you have to look at your picture, right, and determine, remember how we determine which direction is G? We decided that G is going to be negative because I set the direction of movement of being positive going up. So going back here, you will have to just replace, let's see what we have, Vy. It's going to be, now V0y was V naught sine of theta naught. And then acceleration being negative g times t, where t is the time that we already calculated before. So that will be how you calculate Vy. So now by plugging in our numbers, you get something like this, 65 sinus of 35 degrees, and then minus 9.8 times 9.964. Okay, by introducing everything in a calculator, pay attention to your signs, to everything, you get negative 60.36 meters per second. And you're going to ask yourself, what exactly is that negative there? So the negative just shows that is oriented down, and remember down was against the positive that we established, right? Very good. So now let's look at point D. Point D, they ask you the magnitude of the velocity, right? Meaning you're going to have to find that addition of the two vectors that you just did, right? You add two vectors, and part E is the angle made between the velocity vector, the magnitude, and the angle made by the velocity vector with the horizontal. So essentially, let's call this angle different than theta. Let's call it phi. Okay, so at point D, they ask you to find the vector VP. And as you already learned today, but they ask you the magnitude of it, right? That is a resultant vector between the two components right there. And essentially, it's like kind of calculating the distance formula, right? So the vector at VP will be square root of Vx squared plus your Vy squared. We already have both of these components, so by plugging in our numbers here, we get square root of the 5324, which is squared, by the way, and then plus your negative 60.36, which is squared. I didn't get rid of the negative sign because I want you to observe that even if you have a negative, don't get scared. When you raise it to the second power, that becomes positive. So in the end here, by plugging in your numbers, you get 80.48. And those are meters per second. I guess you can round it to 80.5. Okay, so with that said, we got the magnitude of the vector. Now we're going to calculate the direction. So that means you have to find that angle. So remember how if you look at this triangle, right, one of the 90-degree triangle right here, if you do the tangent, you can see that that will be Vy over Vx. So essentially tangent of your angle phi is the absolute value of the Vy over absolute value of the Vx. This time the absolute value comes handy. So nothing else but phi by itself is the inverse tangent of those values. And we're going to replace them in a moment with the numbers that we already got. So we get tangent minus 1 of absolute value of negative 60.36. And that divided by absolute value of 5324. Well, if you plug these numbers in your calculator, then you get that phi is about 48.58 degrees, or simply 48.6 below the x-axis. I think you need to specify that. As I explained before, in many occasions, if you think of trigonometrical direction will be the other way, so you have to see it this way, or just simply say negative 48.58. It's the same thing. Okay, let's see point F. So on that point, they ask you find the maximum height above the cliff top. It's reached by the projectile. So if I zoom into here for a moment, I'm going to have this height that you need to calculate. Okay, so this height right here is the one that is required. It's the maximum height above the cliff. So I'm going to go here and write down h max. And then knowing that the total height that the projectile can reach is going to be the original height of 115 plus whatever we calculate for the h max. So let's go ahead and do that. All right, so now I'm going to use the Galileo formula for this. Why? Because that one has velocities and height in it. So Vy squared, right? It's V at final or V at some point equals V initial squared. And this is again on the y direction plus 2 times the acceleration in that direction, in this case y. And then y minus y0. Okay. So right now, I want you to think about what happens at the top. At the very top, there is no velocity. So this guy right here is going to be 0. Great. So now once I know that, I also know the component on the y direction, which is v0 sine of theta 0. Okay. And then acceleration is negative g. And y minus y0 is nothing else but the difference between the 2 points I'm comparing. So what am I comparing here? I'm comparing between these two limits, right? Here and here. That's the y and y naught for this case, right? For this leg of the problem. So let me zoom out and go back down. And I just wrote the general equation, and now we're going to actually depict it a little bit better. So we're going to go 0, and then here's v naught sine of theta naught so far. And this is all squared. So pay attention to that. Many students forget this and forget to raise the whole parenthesis to the second power. So pay attention to when you do that. Okay, and as I said, acceleration on the y-axis is negative, so I'm going to have negative 2g. And now the y minus y0 for my problem is that little h max. Right, so h max. Great, so if you isolate h max out of here, you get h max. It's equal to nothing else but v naught squared times sine square of theta naught, all divided by 2g. And this is what you were asked to find. And now if you plug in our numbers, let's see, 65 squared times sine square of 35 degrees, and divide that by 2 times 9.8. Please use your calculator, and you get about 70.9. So in other words, from the point of launching the object to the maximum point, so from this point right here to the maximum point, this distance right here is your h max. All right, so with that being said, there was nothing else in there, but if you can have like another question I will add there, it will be, what is the total height reached by the projectile, right? So the h total, especially when you're dealing with a cliff, that could be another question. It's going to be h max, right? It's the total altitude reached above the cliff plus what is below, right, into the cliff area, h cliff. So simply you just have to add the numbers, and in the end you get like what, 185.9 meters. And that's a simple addition I did to the text that was there. All right.